Hi everyone, I'm Steven. Um, Today with me is Reddy, and together we're going to be sharing about Soda Foundation and also how what we're doing to try to unify data and storage management through the Soda Open Data Frame. I'm going to be introducing first what Soda Foundation is about, and then after that introduce the open data framework, and Reddy will cover some of the use cases as well as the other projects that are under Soda Foundation ecosystem. So Soda Foundation is a foundation that focuses on open source data and storage. It was launched back in 2020, June of last year, and is charted under Linux Foundation. There are three mission points that we try to accomplish. First is to foster an ecosystem of open source data and storage management software. And second is to offer a neutral forum whereby all the different data and storage projects can come together to collaborate and integrate so as to fulfill the third mission, which is to provide end users with quality end-to-end solutions. So the foundation is supported by the members that you see here. There are different tiers of members, and besides the enterprises that you see on the screen, there are also we also partner with different associations such as SNEER organization. So the members, as you can see, comprises of end users as well as vendors. So the Open Data Framework and the other projects that we are developing are designed for end users. So the end users represent some of the largest organizations and most innovative companies around the world. They provide guidance to SODA by providing real-world use cases and requirements. And SODA provides a neutral forum for them to address data and storage challenges together. We did the data and storage trends survey together with our partner Linux Foundation research team back in April. And we're wrapping it up right now to try to produce a report. So this survey itself was done in conjunction also with our partners at CNCF, SNEER, OIF, and the others partners. So this report that we are trying to provide, it will provide in-depth insights into the data and storage trends, and hopefully there will be something that's useful to everyone. So if you're interested in getting this report, please follow us on Twitter or LinkedIn. And then when we are ready with the report, which should be sometime in October, we'll publish it, and then you can get the report and provide us with feedback on what you think about it. So Soda Code 2022 is an event that we are organizing. This is right now in the planning stage. The purpose of this event is that this is a data and storage hackathon. It will be the time frame is like the Q1 of next year, and we invite projects or any kind of open source data management or storage projects to join the hackathon. We also invite developers, if you're interested, please join us. You can write to this email address, hackathon@sodafoundation.io, if you're interested, and we will notify you when we have more information for the event when it's ready. So next, I'm going to introduce the Open Data Framework. So this is the typical enterprise IT that consists of like individual technology stacks for file storage, containers, backup, and so on. So these stacks, most of the time they are proprietary kind of solutions that rarely interconnect or share resources, creating an environment that's full of silos that's hard to monitor and control. Infrastructures often span multiple data centers, multiple clouds, and sometimes also the edge. And this adds to the challenges in monitoring and control of data and storage. Some of the challenges would be like how redundant and obsolete data taking up storage, the performance problems due to placing data in the wrong storage tier, or protecting data wherever they may be located, and retaining and securing data for laws and regulations like GDPR. So all this lead to operational inefficiencies and security risks. So how can we address these challenges? We believe the solution lies in an open data framework. So the open data framework connects storage to containers, VMs, and other platforms, and provides a centralized view and control of data and storage in the whole infrastructure. This framework also provides data and storage services such as block, file, and object storage, backup and recovery, security, and compliance. The whole idea is to unify data and storage management with a single open framework across the core, the cloud, and the edge. This is an example of how the open data framework can be used. And this example shows the ODF for connected car platform. For instance, if you take like data that comes in from the connected car, it goes into tier 1 storage. So in tier 1 storage, it may be used for like real-time analytics and stuff like that. So data that sits there for, let's say for after a month, it may no longer be useful. So it needs to be moved to tier 2 storage for things like machine learning or historical training kind of stuff. So, and data may sit in tier 2 storage for like 6 months. And after that, the data may be moved to the cloud or to the cold storage for archiving. So this data lifecycle kind of and tiering can be managed actually through the open data framework through policies. So there are other things like what this open data framework can provide for a platform like this are things like block file and object storage services, backup and recovery, security and compliance, and so on. So some of these things have been developed, and some of them are still, still in planning. So we hope that through the community developers, we'll be able to build something that's going to be useful for a car platform like this. So this diagram shows what the ODF is about. The ODF open architecture provides an open API for integration with platforms and applications. And ODF offers plugins for seamless integration with Kubernetes, OpenStack, and VMware. The storage profiles offers policy-based storage provisioning, data protection, data lifecycle, and other data management functions. The heterogeneous storage connect via the dock to CSI, Swordfish, OpenStack, Cinder, and Manila interfaces. And the performance can be monitored together using the SODA dashboard. And the multi-cloud controller offers access to the various cloud providers through a single S3 interface. So this enables operations such as cloud tiering, cloud backup, and so on. So with ODF, the users can easily build end-to-end solutions with any storage, any platform, and any cloud. ODF, the APIs are based on SNIA Swordfish standard. So we leverage the Swordfish management profiles And with that, we are able to speed up development and ensure interoperability with the Swordfish ecosystem. The ODF storage API includes storage provisioning with policies for replication, snapshots, and retention. So the multi-cloud API supports the major cloud services and operations such as data lifecycle management. The monitoring API enables storage performance monitoring with IOPS, throughput, and other metrics. So with API first design, all the functions in the ODF are accessible and can be easily extended to support new requirements. As mentioned earlier, storage can be connected to the Open Data Framework by different management interfaces. ODFs currently support all CSI drivers and allow multiple drivers to be plugged in at the same time. So Reddy is going to show later on the advantage of using a single SODA CSI driver versus the individual drivers that are provided by the vendors. Besides that, Open Data Framework also supports OpenStack Cinder block storage and Manila file shared storage drivers. So this shows the history of the Open Data Framework. Open Data Framework was initially we started it as a project that's called OpenSDS back in 2017, and that project was mainly confined to a SDS software-defined storage controller. And after that, we expanded the scope, to cover things like containers, multi-cloud, and so on. And that's why we expanded it to be like Open Data Framework. And with that, we also transformed the initial project to SODA Foundation. So since we launched back in July last year, July 2020, we had our first release with V1.0, and that was the federal release. So and then what we are doing right now is that we have quarterly releases, and each of these releases is named after islands and in alphabetical order. So we have Faroe, Greenland, Hawaii, Isabella, and now Gerber. And the next release that's coming up is the K release, Kalpini. That will be sometime in October. So with open source, open standard, open ecosystem, and open collaboration, we believe the Open Data Framework will be able to meet the needs of most end users and help users unify data and storage management with a single open framework across the core, the cloud, and the edge. So with that, I'm going to end my part of the talk, and Reddy will be taking over to show you the Open Data Framework use cases, as well as the other projects that are part of the SODA ecosystem. Thank you very much for your time.
Thanks, Stephen, for the nice intro and SODA Open Data Framework overview. I'm going to cover the ODF uses, specifically within the context of container and the edge data management. And then I will briefly touch upon the SODA incubation and the eco projects that provide complementary data services to the SODA, the implementations. SODA Open Data Framework has the container data management capability. Now, through the SODA CSI driver that can manage, a wide variety of storage backends. So that's really the key benefit when you use SODA CSI driver that plugs it into the container orchestration engine. On top of that, all the data management services that we have currently, enable, as well as the future ones, you can actually take advantage of those services transparently without actually going and rewriting the CSI driver. The control plane is the focus. No changes to the data plane that you normally see with any storage backends. So our goal is to essentially bring in the control plane activity for wide variety of storage backends, including the edge storage, and be able to manage them through the unified SODA CSI driver and the container data management framework. If you look at the differences from the traditional CSI drivers, let's say you have 3 different zones, you essentially end up having 3 different persistent volume claim requests because you're managing each one of these zones on its own merit through the vanilla CSI framework. Whereas in SODA CSI, all the storage backends are actually unified through the the CSI driver, SODA CSI driver, and you can actually bring in any new storage backends without actually changing the CSI driver. And then, of course, you can take advantage of the data management services that we have available in the SODA framework. Our plans currently, we have CSI plug and play driver, as you can imagine, and then we have support for a wide variety of storage backends through the CSI driver framework. We also have container data production framework implemented, which is based off of RESTIC. So you can actually take snapshots and then back them up in the cloud through policy-based implementation. And we plan to continue the CSI enhancements and with focus on data production services, things like snapshot, backup, recovery, enhancements, as well as the monitoring capability. While the focus has been quite a bit on the SODA, the core integration through the data management platform, we wanted to make sure that we can manage the storage resources seamlessly between from the edge to the cloud. So in that context, SODA has the CSI interface that actually plugs it into KubeEdge framework, which is fairly lightweight. And of course, it brings in all the key benefits that you normally get from the SODA framework, which includes ability to integrate different storage backends on the edge, but be able to actually seamlessly provide data management services between the edge and the cloud. Right. So that's the SODA edge focus. So by combining the edge computing platform services with the data management platform services, we can actually manage the SODA, the storage resources, seamlessly from edge to the cloud. So let me cover briefly on the SODA projects. We have 2 types of projects: incubation projects and eco projects. Incubation projects are the ones that natively follow the SODA governance model. Eco projects are the ones that have their own governance model, but provide complementary services to SODA, foundation layer services, data management services, so that the customers can actually benefit from, the broader data management, functionality. The first one is the eco project. The incubation project, which is called DAOS. DAOS is the Intel developed project. This is organically developed from the ground up to take advantage of the non-volatile memory, media, performance, attributes, as well as the storage class memory. So the intent here is to essentially exploit all the media performance attributes by having a truly lightweight data plane layer, including zero copy semantics and non-blocking data metadata operations and so on. And then, of course, at the same time, we need to be able to actually deliver the traditional scale-out type of functionality. This includes the ability to distribute your data among different fault domains and be able to rebuild the data if anything fails, be able to replicate or erasure code to provide the data redundancy with end-to-end data integrity mechanism, and so on. The second incubation project is IG. IG is another object storage. It's developed by China Unicom. In fact, this is being used in production by China Unicom. So the concept behind IG is you have islands of Ceph clusters where you can actually manage them independently without complicating the rebalancing and rebuild activity. When you have a bigger Ceph cluster, and you manage them through the IG software object management layer that has the metadata through S3 API, uniform namespace, and IG uses the Minio to provide that uniform S3 API interface to the clients, and then it manages the metadata and the caching through the database infrastructure, TiDB and MySQL, to deliver high availability and high capacity solution. LINSTOR is the project that is actually developed by LINBET. LINSTOR basically provides replicated block storage, functionality among pool of machines. It can manage wide variety of media, hard disk drive, SSD, NVMe SSDs, as well as PMEM, and it can actually expose this media through iSCSI, traditional iSCSI, as well as NVMe or Fabrics type of interface, with a native Kubernetes CSI driver integration to deliver high performance type of attributes that are needed. It can manage them. It can manage different types of media through tiering. So you can actually have pool of hard disk drive. You can have pool of SSD, and you can actually manage the lifecycle and also control the movement of data through live migration and so on. That is required for the enterprise manageability. Things like data dedupe, geoclustering, as well as the the high performance are the key attributes of LINSTOR stack. The next one is OpenEBS. OpenEBS essentially provides native integration to Kubernetes to enable the stateful applications that require dynamic, persistent volume capability, whether it is local or replicated. OpenEBS is developed by Maya Data. It is part of CNCF sandbox. And the intent of OpenEBS, at least the one critical aspect of OpenEBS functionality, is to support stateful workloads. Stateful workloads like databases require the persistent volume capability and production through replicated persistent volume functionality, which that is typical of what you need for the database services. The data engines are pluggable based on the type of media, type of storage you have. You can actually plug in different types of data engines, and then you can actually provision through the unified control plane, through the and with the CSI plugin into the Kubernetes. So that's OpenEBS. ZENKO is the open source project, by Scality. ZENKO basically provides the storage data management capability that is unified, irrespective of where your data is located, whether it is on-prem cloud or public cloud. It can manage the objects and the lifecycle of those objects, all the way from provisioning the objects to moving the objects among different, the cloud service provider implementations, and be able to actually manage them, through unified, management layer is really the key focus for ZENKO. CORTX is the another distributed object storage system. This is developed by Seagate primarily to take advantage of the high hard disk drive utilization. You're looking at multi-terabyte hard disk drives in the market, and the object storage system that is meant to take advantage of that capacity with the efficiency that's implemented behind the scenes to be able to, take advantage of all the capacity that hard disk drives provide. It also has a capability to integrate with other storage backend. So things like, let's say you have a tier that manages the high performance media, and you can actually take a backup from, let's say, Intel DAOS, and store that into the CORTX, the storage software platform. So the ability to actually, provide integration capability to deliver, tiering type of implementation is also part of CORTX functionality. So those are the incubation and eco projects. As Steven talked about in the beginning, Soda Foundation essentially provides open source data management framework that brings in the data services as well as the wide variety of storage backend management, all the way from the edge to the cloud. And we are here to actually integrate any other complementary data and storage projects out there that are open source in nature that can actually benefit from the collective, Soda Foundation investment, as well as the, the adoption. We would love to actually, look for your contributions, either it is in the open source development or CI testing, or as an end user. In general, we look for your participation in any one of these Soda, aspects, all the way from the development to the, adopting the Soda-based, solutions. The upside is when you are participating in the Soda Foundation, one, you get the existing, the community engagement, and you can contribute and you get the credit for that. Two, you essentially get to speak in the Soda conferences, and then obviously the the brand recognition and the press release and all the marketing benefits that you can actually take advantage by participating in the Soda community. With that, thank you for your time. We appreciate your time. Thank you.